All right, let's just dive right into this explainer. We're going to master the Florida GC Project Management exam by literally building a project from the ground up. If you're looking to really grasp these visual study sheets, the core concepts that actually control a construction job site, well, you're absolutely in the right place.
But hey, before we break ground, I want you to consider this. What single event is a top 3 cause of job site fatalities and, obviously, a massive focus for OSHA enforcement? Think about it for a second. It's trench collapses. And honestly, this perfectly highlights why knowing the precise numbers behind site management isn't just about passing a test. It's literally about saving lives.
So we're going to tackle this in 5 distinct phases. We've got site layouts and plans, soils and earthwork, concrete and masonry, wood and metal framing, and finally, those absolutely crucial OSHA safety rules.
Let's kick things off with Section 1, Site Layouts and Plans.
Every successful project actually starts way before a shovel ever hits the dirt. Think of the site plan as your project's master control map. Being able to interpret setbacks, easements, and grading arrows, that dictates exactly where your work goes. A setback is just that required open distance from a property line, while an easement, well, that gives another party legal rights to use part of a land for things like utilities or drainage. Make a mistake here, your entire project could shift completely out of compliance.
Now, the absolute most crucial point on any site plan is understanding your benchmark. This is your permanent reference point, your known elevation. If you get this single elevation wrong, your entire project's elevation is completely ruined. Think about it. Every finished floor, every drainage path and grading slope relies on this one fixed point. No pressure, right?
Moving right along to Section 2, Soils and Earthwork.
So the capacity of the dirt actually dictates the foundation you're going to build on. It's a direct relationship. Especially with Florida's notoriously high water tables, soil conditions dictate everything. Got good bearing near-surface soil? Great, you can use shallow footings. But if you hit weak soils or high groundwater, which, let's face it, usually means heavy dewatering to keep your excavation dry, you've got to transfer those loads way deeper to stronger strata using piles. Ignoring this? Yeah, that leads to settlement, cracking, and just complete foundation failure. We definitely don't want that.
To prevent that shiny new slab from settling or cracking, you have to compact the soil, right? You got to get those air voids out. But how do you actually know when you're done? Well, you rely on the Proctor test. This is a lab test that gives you the exact optimum moisture and maximum dry density targets. So when you're out there sweating in the field, your compaction efforts are constantly being measured against this lab-tested Proctor target. If it's too wet or too dry, your compaction just fails. Simple as that.
And hey, when you're estimating earthwork, please avoid this classic trap. You always have to distinguish between the loose volume of dirt you just dug up, that's the loose cubic yard, or LCY, versus the compacted volume you're placing back down, the compacted cubic yard, or CCY. Remember, dirt swells when you dig it up, and it shrinks when you compact it. Those two volumes, they're literally never identical. Don't let that catch you off guard.
All right, Section 3, Concrete and Masonry.
With our site properly compacted, it's finally time to pour the foundation and go vertical. Now remember, fresh concrete is a live load hazard. You absolutely must follow this strict sequence. Plan, deliver, place, consolidate, finish, and cure. It's non-negotiable. Your formwork and shoring have to resist immense lateral pressure during placement before that concrete even starts to cure. If you rush the consolidation or maybe mess up the curing process, which by the way is all about moisture retention and temperature control, your entire structure is compromised.
And while we're on the topic of placing concrete, here is a highly tested rule for you. Fresh concrete must never free fall more than 3 feet. That's about 1 meter. If it drops further than that into a form, the heavy aggregates will literally separate right out from the paste, completely ruining the mix. So you've got to use chutes or tremies for those deeper pours to control that drop.
Now, when we transition from pouring concrete to stacking masonry blocks, do not confuse your materials. It's an easy mistake, but a big one. Mortar is what actually glues and bonds those masonry units together. Grout, on the other hand, is a highly fluid material. It gets poured into the inner cavities or cells of the blocks to surround and lock in that steel rebar. So yeah, they look similar, but they serve completely different structural purposes.
Next up, Section 4, Wood and Metal Framing.
Okay, now we're ready to really build out the skeleton of this structure. Take pre-engineered metal buildings, or PEMs. These are manufactured designed systems, and they require incredibly tight coordination. I'm talking anchor bolts, temporary bracing, MEP penetrations. Every single thing has to align perfectly during erection.
And here's the kicker. You absolutely cannot remove any temporary bracing, like knee braces or cables, until the permanent stability of the frame is 100% achieved. No shortcuts.
When you're ordering cold-form steel framing or metal decking, you've got to remember this kind of counterintuitive rule. Gauge is the metal thickness designation, right? But a lower gauge number actually gives you a thicker, stronger piece of metal. It feels backwards, I know, but a 12-gauge piece of steel is significantly thicker than a 20-gauge. Keep that straight in your head.
Now for wood structures, the logic shifts just a bit. You have to establish a continuous load path that transfers forces from the roof all the way down straight into the soil. In a place like Florida, this means using hurricane ties between the roof framing and the walls to fight off severe wind uplift. Oh, and a huge rule here, strict truss handling. Never, and I mean never, alter, cut, or modify engineered roof trusses without official authorization from the building designer. Just don't do it.
And finally, Section 5, Crucial OSHA Safety Rules.
So, we've built a structure, but honestly, none of that matters if the job site gets shut down, or worse, someone gets hurt. Think back to that opening question about fatalities, right? Well, the magic number for excavation safety is 5. Any trench that is 5 feet deep or more absolutely requires a protective system to prevent a lethal cave-in. The only exception? If you're digging entirely unstable rock, which, let's be real, is incredibly rare. Egress is just as critical here. If your workers are down in a trench that's at least 4 feet deep, they can never be more than 25 feet of lateral travel away from a ladder, a ramp, or a stairway to get out safely. 25 feet, that's the limit. And remember, all those spoil piles, the dirt you just dug out, they have to be kept at least 2 feet back from the very edge of the trench. To actually secure that trench, a designated, competent person on your site has to evaluate the hazards daily and choose one of 4 main protection methods. You can slope the sides back, you can bench them into steps, you can shore up the walls with internal supports, or you can use a shield, like a heavy trench box, to protect the workers inside just in case the soil decides to move. Now, the protection method you choose depends heavily on the soil type, and if you're digging in type C soil, which happens to be OSHA's least stable class, covering granular, saturated, or previously disturbed dirt, very common in wet Florida, you need to know this for sure. The benching method is strictly prohibited. Why? Because the soil is literally just too weak to hold a stepped shape. Okay, finally, before we wrap up, I want you to keep this math cheat code handy for the exam and honestly for the field too. To calculate the exact cubic yards you need for your concrete pours or earthwork fill, always take your total volume in cubic feet and just divide it by 27. There are exactly 27 cubic feet in 1 cubic yard. Remembering this simple little conversion is going to save you from making massive ordering errors. So just look at everything we've covered today. By truly understanding the why behind these codes, from benchmarks to trench boxes, you now have the blueprint to manage critical operations. You aren't just memorizing numbers to pass an exam. You're taking on the real responsibility of keeping your crew alive. Armed with these rules, what hidden hazards will you spot on your very next site walk? Keep exploring these study sheets, and I'll catch you in the next explainer.